Okay, so let's solve this problem. So for the addition of vectors using the components method, then we have this problem. So two forces A and B are acting on a particle. Then force A is 3 Newton directed to north, and force B, that's 4 Newton 30 degrees north of east. Then find the resultant force. So first, in a plane, this one is north, south, the east, and the west. Then since force A directed to north, so therefore this one is force A. Then for force B, that's 30 degrees north of east. So this one is force B. Since north of east, so therefore from east going to north, that's north of east, and the angle is 30 degrees. Then to find this resultant force, so first we need to create a parallelogram, and this is now the resultant force. Then using the components method to solve for the resultant force, so for force A, the magnitude, that's 3 Newton, so this one is 3. And for force B, the magnitude, that's 4 Newton, so this one is 4. Then for force A, for angle theta, so take note that for the angle always starts from the east, so therefore from east to force A, so from east to force A, so the angle, that's 90 degrees. So therefore for force A, theta is equal to 90 degrees. Then for force B, for the angle, so again the angle always starts from the east. So from the east to this force B, and the angle is 30 degrees. So therefore for force B, the angle is 30 degrees. Then to solve for the x component using this formula, so we have the magnitude times cosine angle theta. So for force A, so we have the magnitude is 3, then cosine theta, that's 90 degrees for force A, equals, so for the x component for force A is 0. So this one is 0. Then for force B, so the magnitude is 4, then cosine, the angle is 30 degrees, equals, so that's 3.46. So x component for force B, that's 3.46. Then for this y component, using this formula, so for force A, the magnitude is 3, then times sine the angle, that's 90 degrees, equals, that's 3. So y components for force A is equal to 3. Then for force B, so the magnitude is 4. Then times sine angle theta, that's 30 degrees, equals, so the y component for force B is positive 2. Then we need to find the summation of x and the summation of y. So to find the summation of x, we just need to add all these numbers. So 0 plus 3.46, that's 3.46. And for y, that's 3 plus 2, that's 5. So we have now the x component and the y component. So this time we can find now the resultant force, which is equal to the square root of x component squared plus the summation of y component squared. Then substitute now the values. So for the x component, that's 3.46 squared. Then plus for y, that's 5 squared. Then we have now, so that's 3.46 squared. Then plus the 5 squared equals, that's 36.97. So we have the square root of 36.97. So to find out the resultant force, so simplify this one. So the square root of 36.97. So we have the square root of 36.97 equals, that's 6.08. So the resultant force is 6.08 Newton. Then this time, to find now this angle, so to find this angle, so using this formula that theta is equal to inverse tangent summation of y over the x component. So we have now inverse tangent. So for y, that's 5. Then over, for summation of x, that's 3.46. Then we have inverse tangent. So this 5 divided by 3.46. So we have 5, then divide by 3.46 equals, that's 1.4451. So 1.4451. So to find now angle theta, so for this inverse tangent, that's shift. Then tangent, that's inverse tangent. Then 1.4451 equals, so that's 55.32 degrees. So theta is equal to 55.32 degrees, the north of east. So we have the north of east. So therefore the final answer, so we have 6.08 Newton at 55.32 degrees north of east.